Okay, Cindy Schwartz again from Vassar College. Now it's your turn to try to solve a problem involving a ball bouncing off of a wall, and we're going to use conservation of momentum, and we're also going to use impulse to find the force exerted on the ball by the wall. So the first thing we need to do is we need to be given some angle. So the angle I'm going to use in this problem is this angle right here is 75 degrees, okay, which means that this angle is also 75 degrees. Okay, so why don't you pause it right now and see if you can figure out what the initial x and y components of the velocity are. So if we look at the black triangle, hopefully you came up with Vx over 40 is sine 75 and Vy over 40 is cosine of 45. If you have the sines and cosines backwards, you may want to go back and review the SOHCAHTOA and so that you can see that the sine is the opposite over the hypotenuse, and the opposite in this case is the x component. So we can put some numbers in there, and we're going to go to the next slide and see what we've got. So we now have an initial x momentum and a final x momentum. So why don't you see if you can calculate those, as well as an initial y momentum and a final y momentum. So pause the video, do that, and then you can check the results. So hopefully you got the same results shown here. As you can see, we calculated the initial and final x momenta and then took the difference and got a non-zero value. But for the y direction, we got a value of 0. This should make sense because if you think about the direction that the force would be in, the force should be on the ball by the wall, so this should be the direction of F. And as we've chosen our positives and negatives, that direction is positive, and therefore the force should come out to have a negative value.